Okay, moving on to the section 1.6 notes dealing with simplifying polynomials. After this lesson, you should be able to add and subtract polynomial expressions. So just like the last lesson, we're going to begin with some vocabulary. Let's start off with what it means to have like terms. So like terms are terms that have the same variable and same exponent combination. As we get to some concrete examples, right, we will point out again this definition of what a like term is. When it comes to combining like terms, what you will be doing is adding coefficients of the like terms. Remind you again that coefficients are the number values in front of the variable exponent combinations. Next, adding polynomials. When it comes to adding polynomials, you will be simply combining like terms. So here are two examples of adding polynomials. So here we have a trinomial in the first set of parentheses, and we want to add it to another trinomial in the second set of parentheses. Now, again, when it comes to adding polynomials, it's all about combining like terms. Now you notice that the second polynomial is not written in standard form. Remember, standard form has the terms written where the exponent is going in descending order. Now you can go ahead and take the time to go ahead and rewrite that second polynomial in standard form, but know that it is not necessary. Okay, so now let's go ahead and add these two polynomials, which again means we are combining like terms. Like terms are terms that have the same variable and same exponent combo. So I'm going to use my highlighter here to highlight a couple like terms. This 8x squared and this negative 2x squared. Those are like terms because they have the same variable and same exponent combo, x squared. Negative 3x and 4x. And those are like terms because they have the same variable and exponent combo. 6 and a positive 4. Like terms. Okay, so now let's go ahead and combine them. Remember, combining means we are adding the coefficients of these like terms. So 8x squared and a negative 2x squared gives us a positive 6x squared. Okay, it's all about the coefficients. We keep the variable and the exponent combo the same. Negative 3x and a 4x adds up to 1x. 6 and 4 add up to 10. All right, so let's see what you can do with part B. All right, so for part B, instead of using the highlighter colors, I use these different shapes to kind of organize my like terms. So in the circles, I have all the terms that have the x cubed variable exponent combo. Here in the boxes, the squares, I have the like terms with the x's, and in my triangles, I have the constants. Notice that I have this kind of oddball term, the x squared term, right? But there's only one of those, right? So nothing to really pair it with. All right, so again, combining like terms, we are adding the coefficients of these like terms. 16 and a negative 6 and up to 10 x cubed. All right, because I want to write my answer in standard form, I'm going to go ahead and take this negative x squared and put it next. I got the 4x and the negative 10x, which adds up to negative 6x, and positive 3 and a positive 1 add up to a positive 4. So there's my sum of those two polynomials. Okay, so here we want to write an expression for the perimeter of each figure. Recall that perimeter means we are adding up all the sides. So with this triangle, I have sides 8, 7, and 5. So I'm going to go ahead and write down that the perimeter has me adding up all those sides. Okay, so when I add them all up, this one gives me a nice number like 20. Perimeter of this triangle. Now the sides have expressions. So that's okay. We still know that perimeter means adding up all the sides. So I'm going to take this side, which has a measurement of 2n plus 1, add it to this side, which is 2n plus 5, and that third side, n plus 5. Okay, so now we can't leave it like that, and we always want our answer to be its most simplified. So this is where we're going to combine like terms, right? We're adding these polynomials. So 2n plus n gives us 5n. 1 plus 5 plus 5 gives us 11. We should recognize this shape. This is a rectangle. And a rectangle has 4 sides, and where the opposite sides have the same measurement. Important to remember that, right? And if not, again, we want to look at these tick marks. These are marks that we're going to be seeing a lot of later. But these tick marks tell you which sides have the same length. So here we have a double tick mark on this side and a double tick mark on that side. This side has 2t plus 1 as its measurement. So it's safe to say that this other side has the same measurement of 2t plus 1. These two sides have that single tick mark. This side has a 6t plus 5 attached to it. And because of tick marks, and because we know it's a rectangle, we know that this side is going to have 6t plus 5 for its measurement. All right, so now again, we want to write an expression that represents the perimeter of this rectangle. So that means we are adding up all the sides. So again, we can write each individual one out, or because we know that adding up all those sides means that we are combining like terms. So let's go ahead and look at the like terms to combine. I've got a 6t, 2t, another 6t, and another 2t. Those are like terms because they have the same variable exponent combo, t or just t to the first. So I add those all up. I get 16t. I got 5 plus 1 and a 5 and another 1. Add those together, I get 12. So there's the expression for the perimeter of this rectangle. Looking at example number 3, it says use the law of exponents to simplify. Okay, so again, from our previous lesson, we know that we're multiplying the same base. The rule here for exponents is we're going to keep that same base, and then we are going to add the exponents. One of the exponents is 2a, the other one is 5a plus 3, so we're going to add those together. All right, again, multiplying the same base, we keep the base, we add the exponents. Because the exponents are algebraic expressions, we're going to combine like terms to get x to the 7a plus 3. Okay, so now we're going to skip on down to more vocabulary, starting off with the distributive property. So hopefully you can recall from your previous math classes that the distributive property is where we do multiplication over addition and or subtraction. And again, we'll go through some examples here in a minute. Next, subtracting polynomials. Okay, so we're going to kind of use a similar idea that we saw with the adding or subtracting assigned numbers lesson from the beginning of the school year. When it comes to subtracting polynomials, we want to think about adding the opposite. And then finally, simplifying expressions. Okay, so when we're simplifying expressions, we want to try to get rid of parentheses by using the distributive property. And then we also want to make sure we are combining any like terms. All right, so let's go ahead and simplify the following expression by using the distributive property. So here we are subtracting polynomials, and again, when we subtract polynomials, we want to add the opposite. So we're going to make some adjustments. So you see here that with the first polynomial, I went to go ahead and drop that parentheses. We don't need that. But then I changed this subtraction symbol into an addition and made everything in the second polynomial the opposite. Okay, so once we do that, we change the subtraction to addition and made everything in that second polynomial the opposite. Now we go ahead and look to combine like terms. We get 6x squared minus 8x plus 9. Moving on to part B. Here we have that number hanging around inside the parentheses for both. So again, we're going to use the distributive property as you learned in your previous math class. So you can see here, after you distribute both parentheses, the parentheses drops. Okay, so now we're looking to combine like terms once again. And we get 8x cubed plus 2x squared plus 4. All right, so now let's see what you can do with part C. Right, so for the first polynomial, I want to go ahead and distribute that -3 through the parentheses. So we got -6x minus 12. We're going to take this minus sign here, and we're going to change it to a plus, and make everything in the second polynomial the opposite. Right? So again, it's only when you're subtracting are you going to change the subtraction to addition and make everything in that second polynomial the opposite. All right, again, always remember with these polynomials, you got to write your answer in standard form, looking at the exponents of the variables and writing them in descending order. All right, so next is the U-try. Let's have you guys try again to see if you can simplify this expression in part D and then find the length of the missing side using the concept of perimeter. All right, so take a moment to check your work and answers with mine. I'm going to make note that you got to be careful again here inside the brackets where we have to do some simplifying first before we do anything with changing things to the opposite. And for part E here again, I started with knowing that the perimeter of the entire rectangle triangle is 36. I took 36 minus one side minus another side to get me the value of that missing side. All right, so again, let's apply your knowledge of the topic of the lesson to see if you can figure out the answers for these next three. Okay, so for part F, again, we are told that the perimeter of this triangle is 13x plus 11. So we want to find the length of this missing side. So again, using the model of the last example, we're going to start with the perimeter, and we're going to subtract each of the two sides that we have. But when we subtract these two sides, because the sides are given as polynomials, we need to apply that rule of adding the opposite. All right, so here I have adding the opposite. Adding the opposite, right? All of these, I added the opposite. And combining like terms, I get 4x plus 7. With the last two examples, we're going to use those exponent rules that we learned earlier in the unit. I'm multiplying same base, I keep the base, and I add the exponents, right? I'm adding the exponents. For here, because we're doing division, we're going to keep the base, and we're going to subtract top minus bottom exponent. And again, because we are subtracting a polynomial, we need to add the opposite. And then we combine like terms. Okay? So again, if you have any questions, let me know. If not, go ahead and get started on the homework.